girl swinging a yo-yo above her head, spinning it in circles, and the string breaks and is replaced with a second string. Now we're given two pieces of information in this. We're given that the first one, that the velocity at which she's spinning it stays the same before and after the string breaking. So we can say velocity of the first is equal to the velocity of the second. The second piece of information is that the second string is 1.5 times the length of the first string. So we can say the length of the second string is 1.5 times the length of the first string. Now, since she's spinning in the circle, the length is actually going to be our radius. So when it comes down to doing centripetal acceleration in v squared over r, the radius, L is just going to be radius. R2 is 1.5 R1. Okay, so what we're looking to find now is actually the tension in the final string. When we replace it, what is the tension in terms of the original tension? So let's find tension 2 in terms of tension 1. Okay, so tension is a force. Now, what we're going to do with this is start off with sum of the forces. Is equal to mass times acceleration. We're going to do this for the first string, and we're going to do it for the second string. Okay, let's start off. Sum of the forces. First string. All we have for forces is one tension. That's all we have for a force. One tension. And that's equal to mass of the yo-yo times its acceleration. And that's just centripetal acceleration. We know centripetal acceleration is v squared over r. So we just plug v squared over r in for the acceleration. v1 squared over r1. Okay, let's do the same thing for the second one. Second tension is m v2 squared over r2. Now we have to solve. We have to solve for t2 in terms of t1. We have one vital piece of information, is that the velocity remains unchanged. So all we have to do first is I'm going to solve for each of these velocities and just set them equal to each other. So we get t1 multiply r1 over, divided by m, that's equal to v1 squared. Same for this side, multiply r2 over, divided by m, that's equal to v2 squared. Okay, v2 squared, v1 squared and v2 squared are the same thing. v1 equals v2, v1 squared equals v2 squared. So I can just set these two equal to each other. So t1 r1 over m equals t2 r2 over m. Now m's are going to cancel out. I just multiply both sides by m and they cancel out. And I want t2 in terms of only t1, but I have r1 and r2 here. So I need to get rid of those. But the other piece of information I have is r2 is 1.5 r1. So instead of r2, I'm going to plug in 1.5 r1. So t1 r1 equals t2 times r2, which is 1.5 r1. Now we see that we can divide both sides by r1, and that'll cancel. And we will get divide by 1.5, so t1 over 1.5 is equal to t2. So now we have t2 in terms of t1. t2 equals, and if we divide, just get t1